110, 10-4.
14, nice out, Connie.
10-4. 109.
1098 Northport.
10-4.
117, no signs of distress. 1098 Northport.
Oh. Five, 10-13.
10-4, written warning, white mountain.
Oh.
261 Titusville.
261.
Signal 54, Sandpoint Park.
10. I'll go to BC, so on countywide. Is scene secure at Cocoa Estates for medical? I was actually just calling fire rescue to cancel that. I copy. Okay. Call 52 towers full. Done. Quick, Charlie and I might get 10 north hop. Jump. Minnesota 257, 1065, 40 Romeo at 3785 Sawgrass Drive.
2 more, 26 on call. 10.
Nice launch trajectory and countdown net. Pad is clear.
10, 9, 8.
Launch auto sequence has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Show me a 10-6 at wrong north GMC for vehicle maintenance. 10.
Vehicle is supersonic. Stage separation confirmed. Dragon separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
Hello, everyone, and thanks for joining us for our launch today. Falcon 9 is set to lift off from Space Launch Complex 40 in Florida just under 17 minutes from now. Our 243rd overall mission to date and our 44th mission of the year. My name is Jesse Anderson, and I'm an Integration and Test Engineering Manager here at SpaceX. And today we have a really cool payload on board the second stage. We're sending a space telescope for the European Space Agency to a Sun-Earth L2 transfer orbit, also known as the Sun-Earth Lagrange Point 2, which is nearly 1 million miles beyond Earth's orbit. This telescope's mission is to help answer the question...
LOX float has started.
To help answer the question, what is the universe made of, by exploring the cosmic mysteries of dark matter and dark energy. It will create an unmatched 3D map of the universe by observing billions of galaxies across 10 billion years of cosmic time across more than a third of the sky. The mission today was named after Greek mathematician and founder of geometry Euclid of Alexandria, and since the density of matter and energy are linked to the geometry of the universe, the mission was named in his honor. The spacecraft today was built by the European Space Agency, or ESA, with contributions from the Euclid Consortium and NASA. In fact, over 3,500 people from 21 different countries were involved in making today's mission possible. After launch, Euclid will have a month-long commissioning phase while traveling to its final destination. After 2 months of performance verification, it will then be ready for its science operations to begin. ESA will need some time to process the data, but is anticipating sharing the first images with the public in the fall. In just a few minutes, we'll be joined by members of the ESA team to talk more about the mission, so stay tuned. At T-minus 15 minutes and counting, we're well into propellant loading on the vehicle. Both the rocket and spacecraft are healthy. Weather is green and looks great over there in Florida, and range is ready to support liftoff at 11:12 a.m. Eastern Time. We do have a backup opportunity tomorrow at the same time if we don't lift off as scheduled today for any reason. Our Falcon 9 rocket and the Euclid payload rolled out to the pad from the hangar yesterday and went vertical a couple hours later. Now looking at the very top of the rocket is the payload fairing, or just fairing for short. And there you can see it on your screen. The fairing is made up of 2 composite halves that come together to encapsulate the Euclid payload in order to protect it from aerothermal loads, heating, and contamination during ascent. Now you might be able to tell that the fairing halves supporting today's mission are brand new. Once we reach the vacuum of space, the fairing halves will separate, and we'll attempt to recover them for potential future use using our recovery vessel, Doug. Now below the payload fairing is the second stage, which is responsible for taking our payload to its drop-off orbit in space. Today's launch marks the first mission for SpaceX taking a payload with a final destination of a Sun-Earth Lagrange Point 2 orbit. Right under the second stage is the inner stage, which connects the first and second stages together, in addition to housing the Merlin vacuum, or what we call the MVAC engine, on the second stage. The inner stage is equipped with pneumatic pushers that allow stage separation between these 2 stages during flight. Once separated, the second stage will continue on its journey in space, while the first stage will start making its way back to planet Earth. And speaking of, the bottom 2/3 of the vehicle is what we're referring to when you hear the term first stage. You may also hear it being referred to as the booster. The bottom of the booster is equipped with 9 Merlin engines, and that gives us the 9 in the name for Falcon 9. These 9 M1D engines are used to accelerate the vehicle through the Earth's atmosphere and into various orbits in space. You may be able to tell by the soot on the first stage, but this is the primary part of the rocket that gets reused multiple times. The first stage supporting our launch today is flying for its second time, having supported the AX-2 mission just about 6 weeks ago. After liftoff and stage separation, we'll be attempting to recover the booster using our drone ship, which you can see there on your screen, a shortfall of Gravitas, which is currently stationed in the Atlantic Ocean. With liftoff currently set at 11:12 a.m. Eastern Time, let's learn a little bit more about today's mission.
In 1915, Albert Einstein astonished the world with his general theory of relativity. It described the behavior of the entire universe based on the matter and energy contained within it. The theory sparked the modern discipline of cosmology and the hope that we would finally understand how the universe came to be. But in recent times, the effort to define what the universe is made of has given us a very big surprise.
1098, arrest report.
Visible stars and galaxies make up less than 5% of the universe's total matter and energy. Beneath this visible layer is a mysterious celestial realm, consisting of shadowy particles and unknown energy fields. For decades, astronomers have puzzled at their nature, calling these elusive substances dark matter and dark energy. ESA's Euclid mission will go in search of the answer to the fundamental question: what is the universe made of? A European-designed mission, Euclid is built and operated by ESA, with contributions from the International Euclid Consortium and NASA. ESA selected Thales Alenia Space to lead on building Euclid, with Airbus Defence and Space providing the telescope and payload module. The telescope and scientific instruments form the heart of the mission. Together, they will observe billions of galaxies over more than 1/3 of the sky. Producing record quantities of data, Euclid will enable scientists to draw a precise map of the universe across space and time. This will allow researchers to investigate the effects of dark matter and dark energy on the apparent shape of galaxies and on their motion and distribution over immense distances. In time, this will help reveal the true nature of dark matter and dark energy. The spacecraft and data communications will be controlled from ESA's European Space Operations Centre in Darmstadt. To cope with the vast amounts of data Euclid will acquire, ESA's S-Track network of deep space antennas has been upgraded. These data will be analysed by the Euclid Consortium, a group of more than 2,000 scientists from more than 300 institutes across Europe, the US, Canada and Japan. Understanding the elusive nature of the universe has drawn astronomers throughout history. It remains one of the most challenging investigations in modern science, but Euclid is up to the task. The Euclid mission is a quest into the unknown, a mission to shine a light on the dark side of the universe.
Euclid is SpaceX's first mission to a Sun-Earth L2 transfer orbit, also known as the Sun-Earth Lagrange Point 2. The Sun-Earth L2 transfer orbit is nearly 1 million miles beyond Earth's orbit and a most ideal orbit for space-based astronomy because telescopes in this orbit, like the James Webb Telescope, can keep the Sun, Earth, and Moon behind them while being close enough to transmit large amounts of data to Earth and receive solar power from the Sun. Now, in order to get the rocket and payload into any orbit, the rocket has to not only go up really fast, but it also has to go sideways. As we ascend, we tilt the engines, and that turns the rocket horizontally. To help demonstrate this concept, imagine firing a cannon from a really high mountain. The cannonball will arc, and then good old gravity will pull it back down to Earth. As you increase the power, the cannonball will arc and land farther and farther away. Eventually, if you could continue to increase the power, the cannonball will end up in free fall around the Earth. Basically, gravity is pulling down on the cannonball, but it's going so fast that it never hits the ground. This arc that constantly misses the Earth is Falcon orbit. Falcon 9 effectively does the same thing as the cannon in this example. It provides enough power and horizontal velocity to the spacecraft on board the second stage that the spacecraft is placed in orbit around the Earth. You'll be able to see this today by watching the orientation of Falcon 9 after liftoff. The rocket will go straight up until about T plus 10 seconds, at which point we begin that shift in orientation by gimbaling the engines so Falcon 9 can go horizontally really fast. So be sure to look out for that after liftoff. With about 7.5 minutes left until liftoff, we are joined by NASA's Megan Cruz and ESA's Director General Joseph Aschbacher over at Kennedy Space Center in Florida. Hey, Megan, how's it looking over there on the East Coast?
Hey, Jesse, welcome everyone to Florida and NASA's Kennedy Space Center. We're just behind us. We are waiting to see Euclid launch on a Falcon 9 rocket right off the launch pad behind us. As you said, joining me this morning is Joseph Aschbacher, the Director General of the European Space Agency. Good to have you here this morning.
Glad to be here every time.
Yeah, I love that you're here. And yeah, just talk to us about how Euclid's launch that we're about to see in a few minutes comes on the heel of a great year for you guys at ESA.
ESA had really a fantastic year. We just came out of a ministerial conference conference in November last year, plus 17% more budget, many new projects, many new activities, so quite fascinating. We have selected 17 astronauts. Some of them will fly from here into space. We have just signed an agreement with Axiom. We're having 5 astronauts in training right now at the Astronaut Center. We have launched JUICE earlier this year. JUICE is an amazing mission which fits very well with Euclid, which is looking at habitability of the icy moons of Jupiter, something quite unimaginable, just as crazy as Euclid, dark matter, dark energy, which is really amazing. So we have a lot to do. We have a Space Summit coming up towards the end of the year, where we want to raise the profile of space in Europe to top-level politicians and to see what Europe needs to do to really be a strong space power, also to our partners in America.
Right, and in order to foster that, the space industry, I mean, one of the reasons you really want to do that is to also address a global issue that we here at NASA really care about as well.
Oh yes, we do. We have many satellites that look at our planet. Climate change is the largest problem on our planet for many decades to come, if not centuries, and we need to do everything we can from space. We have the Copernicus program, we have Meteor program, we have just launched MDG-1 last year, fantastic images that just came out, and we really make sure that we use our space assets to the best of humankind, and climate change is one of our big concerns. And one element which we just launched is not only on ground that we want to see at climate change, also in space. And I'm about to really initiate a zero debris charter where we would like to encourage people worldwide to not pollute our orbits. That means if you put a satellite up, you put it down at the end of its lifetime, and that's a new initiative we are doing.
Right. And any words for all the scientists that are hoping to really learn a lot from this Euclid mission?
Oh, the incredible science will come out. I'm pretty sure some Nobel Prizes will be won based on this data. This is really a fascinating mission. I'm so happy. I thank my community, my member states, industry, NASA also as a partner, and all the contributors to this. And thank you so much for this contribution.
Well, congrats to you, and I can't wait to see Euclid launch.
Thank you.
Thank you so much. Back to Hawthorne.
Thanks, Megan. We are about T-minus 4 minutes and 40 seconds away from liftoff. And at this point in the countdown, the clamp arms are going to begin to open up beneath the fairing, and then the transporter erector will begin to retract away from the vehicle in preparation for launch.
Retract has started.
And there we heard that call out. And you can see the clamp arms just below the fairing there on your screen. Those should begin to open shortly here. Once those are fully open, then the transporter erector, or what you heard called the strong back, will retract away from the vehicle. And there you can see the clamp arms opening up there. Again, once those are fully open, the TE will begin to slowly retract away from the vehicle. And it is very slow and slight, but the TE is now beginning to move away from the vehicle. At this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Both first stage and second stage should finish prop loading about a minute apart from each other. First stage finishing up at T-minus 3 minutes, and second stage at T-minus 2 minutes. At T-minus 60 seconds, Falcon 9 will be in startup. Now, what that means is the rocket's autonomous internal flight computers will have taken over the launch countdown. Just inside of T-minus 2 seconds, we light the Merlin 1D engines for liftoff. The Euclid payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket. Currently, both the vehicle and payload are healthy.
Stage 1 LOX float is complete.
And we're looking good for an on-time liftoff at 11:12 a.m. Eastern Time. So let's send it back to Megan over there in Florida.
Hey, Jesse, you can start to feel the energy here at NASA's Kennedy Space Center. We're just behind us. We are waiting to watch the Euclid spacecraft launch atop of Falcon 9, again, on the launch pad right behind us. So with me now is Carol Mundell. She is ESA's Director of Science. Really great to have you here today.
Hi, Megan. Great to join you.
So talk to me about why studying dark matter, dark energy, why is that so important to understanding our universe?
Yeah, sure. This is one of the biggest unsolved problems in modern physics. So we actually think we understand only 5% of the universe, with the matter that we see, galaxies, stars, planets, ourselves. So 95% of the universe, dark matter and dark energy, is still a mystery and enigma, a huge frontier of modern physics that we hope this mission will actually help to push forward.
So then how do you go about detecting things we can't see?
That's a great question, and because this sense of darkness really comes from the fact that dark matter does exert gravitational pull, so we see the effect of it. We look at galaxies and they spin too quickly for the number of stars and the amount amount of gas they have. We look at the clusters of galaxies in the universe and we see too much mass. And so we don't know what fills that mass. It might be exotic particles. It might be that we've got our equations wrong. And on top of that, our universe is expanding. But the really big mystery for modern physics is that expansion is accelerating. So it's actually getting faster and we don't know why. Our equations don't tell the whole story. And so what this mission will do is it will map all of that out to 10 billion years back in history and hopefully tell us the answer to the mystery of life, the universe, and everything.
So then really quick, when do we expect to get this data back to start really analyzing it?
Yeah, so this is a 6-year mission, and the first 3 months of the mission will actually be calibrating the data because this is a huge feat of engineering technology. We have very, very precise images across all of the extragalactic sky, and then scientists around the world, we have 2,500 scientists in Europe and in the US across 9 data centers will analyze these data all the way through 6 years. So our final cosmology answers will come at the end of the 6 years, but we'll do lots of exciting science along the way as well.
Carol, thank you so much. Very exciting.
Thank you.
Thanks, Megan. Thanks, Megan. We are just under 1 minute. Falcon 9 is in startup, and we are just waiting for the final go for launch.
LD, go for launch.
And great news. All systems are go for launch of Falcon 9 and ESA's Euclid Space Telescope.
T-minus 30 seconds and counting. T-minus 15 seconds and counting. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Into ignition, liftoff.
Stage-1 propulsion is nominal.
Vehicle is pitching downrange.
Falcon 9 has successfully lifted off from pad 40 and throttled down to prepare for max Q, which is coming up at T plus 1 minute.
Power and telemetry nominal.
1 minute and about 12 seconds. Max Q is the highest amount of aerodynamic pressures. That's the largest structural load that the vehicle will see on ascent. We throttle down those engines just to pass through max Q, and then we'll throttle them back up once we pass through that period.
Falcon 9 is supersonic. Maximum dynamic pressure.
Great news. We have passed through max Q, getting some excellent views there on your screen. Next up, we have a few events happening back to back. That will be MECO, stage separation, and SES-1. MECO is main engine cutoff, and that's where we'll shut down all 9 of the M1D engines to slow the vehicle down in preparation for its next event, which is
MVAC chill has started.
Stage separation. And that's where the first stage separates from the second stage. Right after stage separation, the first stage will begin its journey back to Earth for landing on our drone ship, a shortfall of gravitas. And during that time, stage 2 will continue on its journey with that third event, SES-1, or second stage engine start run. And that is where the single Merlin vacuum engine will light up and propel the second stage along with ESA's Euclid spacecraft to orbit. In addition to these 3 major events, the fairing halves will separate less than a minute after SES-1, so keep an eye out for all of those events coming up here in just about 15 seconds or so. Again, coming up, we have MECO, stage separation, and SES-1.
Main engine cutoff. Stage separation confirmed. MVAC ignition.
Some really cool views of MECO stage separation, and on your right-hand screen, you can see that the MVAC engine has ignited.
Both vehicles are following nominal trajectories.
On your left-hand screen, the grid fins on the first stage are deploying, and in about 15 seconds or so, we should have fairing separation.
On tilted.
And a very cool view from the ground.
Well, 52 towers, roll 10-8.
Fairing separation confirmed.
10-8.
And there you can see on your right-hand screen that the fairing halves have deployed. Now, as I mentioned previously, both fairing halves are brand new and are now making their way back down to Earth and will be recovered by our recovery vessel, Doug, today. It is T+4 minutes into today's mission, and in order to complete today's landing, the first stage has 2 more burns left. Next up is the entry burn, and that's where 3 of the Merlin 1D engines will reignite. This helps to slow the vehicle down as it re-enters the upper parts of the Earth's atmosphere. Now, that entry burn is coming up in about a couple minutes from now, and that entry burn will last about 20 seconds long. And what you're looking at on your screen, on your left-hand side, is a view from the first stage vehicle, currently making its way back down to Earth, which you can see in the background. And on your right-hand screen is a view from the second stage, looking aft at our MVAC engine.
Acquisition of signal, Bermuda.
That entry burn is coming up here just about a minute and a half
Both
from now.
vehicles continue to follow nominal trajectories.
And good call-outs there. On the bottom of your screen, you can see the speed and altitude of each vehicle as well. And on your left-hand screen, you can see 2 of the 4 hypersonic grid fins that the first stage has. Those grid fins help guide the vehicle as it makes its way back to its landing zone. Again, today we are scheduled to land on a shortfall of gravitas, currently in the Atlantic Ocean, waiting for the first stage vehicle. And on your screen, you're getting a great view from the second stage with the MVAC there and the Earth looking amazing in the background. We're just about 20 seconds away from the entry burn on the first stage vehicle. You may see some white puffs on that first stage. That is nitrogen gas puffs for attitude control.
Stage 1 FTS has safed.
And there you can see the engines have reignited on the first stage on your left-hand screen. This is the entry burn with 3 of 9 M1D engines reignited. And you can see that those engines have shut down. That concludes the entry burn for the first stage. Now we do have one more burn for the first stage vehicle as it attempts to land on our drone ship, and that is the landing burn. It will just be a single engine, the Center E9 engine reigniting, and that is enough thrust to help slow down the vehicle to enable it to touch down on our drone ship. Now during the first stage landing burn, the vehicle will be landing for its second time.
Stage 2 FTS is safed.
Stage 2 terminal guidance.
Vehicle will be landing for its second time today, and just before the landing burn begins, we will also have SECO 1 on the second stage. That is second engine cutoff 1. That's where we'll shut down that MVAC engine on the second stage. This is the first of 2 burns for this mission, and that is coming up here in just a few seconds, followed by the landing burn about 20 seconds after that. There you can see that the MVAC engine has shut down and the landing burn has begun on the first stage vehicle.
Expected loss of signal, Cape. Nominal orbit insertion.
What an incredible clear view of Falcon 9 touching down on a shortfall of gravitas. This landing marks the second successful landing for this particular booster and marks our 204th overall successful recovery of an orbital class rocket, including both Falcon 9 and Falcon Heavy first stages. We also heard the call out for SECO 1 and confirmation of good orbit. So with confirmation of a successful second engine cutoff and first stage landing, we are going to be in a coast phase until just before the second relight of our MVAC engine on the second stage, which will be followed by payload deploy. So sit tight and we'll see you back here around the T plus 17 minute mark. welcome back to the live webcast for the Euclid mission. If you're just joining us, liftoff occurred at 11:12 a.m. Eastern Time from Space Launch Complex 40 in Florida. After liftoff, we also had successful main engine cutoff, stage separation, ignition and shutdown of the second stage, bearing separation, and first stage landing. Now, coming up shortly, we'll have our second burn of our MVAC engine on stage 2 prior to payload deploy, which basically means that we will relight and shut down the second stage engine for a second and last time. Now, SES-2 is coming up here in just about 10 seconds or so. Again, SES-2 is second stage engine start 2, and then we will shut down that MVAC engine about a minute and a half later.
MVAC ignition.
There we heard that call out, and you can see on your screen that the MVAC has reignited. Again, this burn will last about 90 seconds, and it will be the last burn of stage 2 before we deploy the payload. As a reminder, the Euclid payload is still attached to the second stage at this point and will be heading to a Sun-Earth Lagrange point 2 transfer orbit. And that is about 1 million miles beyond Earth's orbit. Now we should have SECO-2 coming up here in a few seconds. That is second stage engine cutoff. Again, will be the conclusion of the second and final burn for this mission.
MVAC shutdown.
We've just had SECO-2.
Nominal orbit insertion.
There's that call out. We just had SECO-2 and confirmation of good orbit. So with successful second engine start and cutoff, we'll join you live to cover payload deployment in about 20 minutes. So we'll see you in a few.
Position of signal, HPK, 26 meters.
once again for the ESA Euclid launch. We've had a great mission so far, and we have just one more major milestone left in our mission, which is payload deploy. Built and operated by the European Space Agency, or ESA, with contributions from NASA and the Euclid Consortium, the Euclid spacecraft will be operated from European Space Operations Center in Darmstadt, Germany. It will explore dark matter and dark energy, which combined is known to make up 95% of the universe as we know it, and create an unmatched 3D map of the universe with time as the third dimension by observing billions of galaxies across 10 billion years of cosmic time across more than a third of the sky. The deployment is coming up here in just a few seconds.
Euclid spacecraft separation confirmed.
And there you can see the Euclid payload drifting away from Falcon 9's second stage. With that confirmation, we'll bring today's webcast to a close. Today's mission marked SpaceX's 243rd overall mission to date and 44th mission of this year. We want to thank the European Space Agency for entrusting us with today's mission and all of you for joining us. If you're interested in following the Euclid mission further, tune into youtube.com/ESA for more. And be on the lookout for the first images from the Euclid telescope later this fall. Thanks for tuning in, and we'll see you again soon.